In this moment, we are unloading the wings from MSN 100 from Beluga aircraft to a logistic platform. So it's the first steps in the final assembly line. The most important thing is the Beluga must be stopped as short as possible. So in this type of operations, the crucial thing is to unload the components, the jigs, the transport jigs, from the aircraft very quick. My feeling is I am working in the best military transport aircraft in the world. We are a big family here and we work hard to satisfy our customers.
Today we are showing you the first production step for the join-up of the full fuselage. The most crucial activity of the Station 700 is the positioning of the sections. It's very important that the sections are very straight in order to assure the best performance of the aircraft. Of course, we are using digital devices in fuselage assembly. We are using 3D printed devices. With this template, we are able to position brackets on a frame very fast and in the right quality.
A400M MSN 100 has finished the structure assembly and is now in Station 500 for surface protection. What we apply here is surface protection on the inside of the fuselage. And after the first step of equipping, the access to the inner skin is not given anymore. So we close the aircraft from the inside. Surface protection is very important for this aircraft in order to secure corrosion protection throughout the life of the aircraft. Well, for me, MSN 100 is important also for the teams to look back what was achieved already. We have stabilized the program, we have optimized the production processes. So the team is very proud of what was achieved during the last years and is eager to go forward. It's very motivated to do the next steps in order to be more efficient.
We are lay down the hydraulic lines for the hydraulic system in the aircraft. We fix the lines on the roof and the top, so the hydraulic is going all over the aircraft. With the hydraulic, we move the rudder, so the aircraft can be handled in the air. The next step is to put the electric in the aircraft, so the rudder can be handled with the electric in. My heart beats for A400M because it's an amazing aircraft. It's so overwhelming when you see this big aircraft in the air.
Currently, we have several main items in production in Nantes, like the radome, the rudder, and the centering box. All the main elementary parts are already produced and are ready to be assembled. A400M is a special program with difficult berths. But let's say the aircraft, the final aircraft, is such a special aircraft that it makes it very attractive, and something special is in the whole Airbus range of products.
In Tablada we have a huge challenge because we have different teams working together. We manufacture the power plant of A400M, we manufacture also the horizontal tailplane, and we deliver also the flap support fairings. Moreover, we have to manufacture the harnesses in the electrical unit. So, to deliver all together on cost and on quality is a huge challenge for our Tablada plant. In our processes and manufacturing, we are using digital tools as the digital bar chart, the digital work order, the iTable.
We are actually building MSN 100 in Station 200, which is a major part for testing the system equipment. So therefore we are using several new technologies, for example, B-Zipler. B-Zipler is an instrument which allows us to work in the aircraft completely paperless. With this opportunity we are able to install, to check, and also to create, for example, non-conformities, if necessary, directly in the aircraft without losing time. It's a great experience to be part of this project and also to bring in the new innovation steps, not only into building, but also for the aircraft as well. I'm here since MSN 1. I delivered the first aircraft to Seville as well. And when you separate the MSN 1 to MSN 100, It's a great job we did here.
At the moment, A400M MSN100 is in station 72. We are performing here the wing join up. The most crucial step in this station are the wing join up, the photogrammetry process, and the final installation of the pylons. In the wing join up, you use laser measurement and a special positioning software in order to achieve the best fit between the main part of the wing. In the photogrammetry process, we scan the surface wing in the junction area in order to get this surface digital. With this data, our programmers are able to perform the numerical control program to machining this part. With this, we assure a perfect fit between them.
In Station 70, we have received MSN100 integrated wing, and our process consists in equipping inner tank, routing and equipping rear and front spar and pylons, and in addition, we perform wing testing. Station 70 is the first station at HAL where we perform functional tests. The most crucial test is wing fuel leakage, because fuel system is not available until the wing is integrated in the fuselage. So we have to simulate aircraft conditions in order to predict the behavior. Regarding digital tools, all activities are planned and monitored by digital performance tracker. In addition, we work with a functional test management system in order to simplify the execution and speed up the resolution of incidents.
The MSN100 from the A400M is currently in the so-called thrust test. It means the first move is hydraulically the door, the ram, the air deflectors and the stabilizer strut.
Here we are in station 91. We have just received this A400M100 from Bremen. We have done the beluga reception and unloading the section, and then we have done the unloading of the section to start the process here in the final assembly line of the A400M. The beluga transportation is one of the most critical logistic challenges we have in the Airbus network. You have to imagine that we have 5 belugas going around Europe and transporting the big sections around the production site, delivering on time, on quality, and on cost. Unloading 100 MSN is a big milestone for us. This implies that we have received almost 250 belugas. I feel really motivated and really proud participating in this big journey and to see how the teams are improving every day and keeping looking for new challenges.
MSN100 is right now in station 60, where we're gonna do the integration in between the nose fuselage and the fuselage. The most crucial step of this station is the integration of the both sections, looking for the best position in between both them to meet design requirements. In this integration process, we use 3 main digital tools. The first one is for the positioning of the sections. We use a laser tracker to measure in a continuous way the position of them in order to meet the theoretically process. The second one, with the gap cam and a specific software, we are getting the gap and step in between the shape of the both sections in order to get the best fit. And the third one, which is the drilling and riveting process, is a continuous process that is measuring and getting data in order to drill and rivet with accuracy needed for this process.
Right now we are on station 40. We perform the aircraft integration with wings and H3P BTP In addition, we performed the first functional test on the aircraft with the first power on. One of the most important parts of the station is the best fit and links measurements because it assures the perfect performance of the aircraft. Although in this station we perform lots of structural work, we have integrated many digital tools like the tablets or the performance tracker in all of the work.
In Station 35, the integrated wiring of the aircraft is tested and verified. We test all electrical systems, communication and navigation systems, pneumatic and hydraulic too. To carry out all these tests, we use the most modern functional digital test systems that combine the use of the functionalities of the aircraft systems with simulation and data acquisition means.
In this station is where we perform the power plant installation, composed by 4 engines, propeller, system, and nacelle. In addition, and in parallel with this assembly, other blue-collar install the APU, the lavatory, the cockpit equipment, and the furnishing. And other teams start to perform some system tests inside the aircraft. The most important step is the torque of the bolts and free up the elements from the tooling transport. But the most crucial is the awareness of the staff in FOD. After 1 year of work, we introduce a system to position the placard inside the cargo. With this system called Samba laser, we project a laser inside the cargo in order to fix the placard in the correct position. After this job, we improve the time installation and we reduce the failure of the positioning.
The most crucial steps at data loading workshop is to upload software into equipment according to capabilities of the aircraft. It provides support from first power on at airframe area to transfer of title at delivery center. In data loading workshop has occurred a big change from cybersecurity point of view. Several digital tools are used along the industrial processes like automated system for uploading, the most advanced application for software verification, and specific antivirus in order to check not only the integrity of data, but also the absence of virus and malware.
MSN 100 is right now in the first outdoor station of the FAO. This is where the tests are done that cannot be carried out indoors for safety reasons. The flight clearance tests are also completed here since they require real operating conditions of an aircraft. For example, fuel or communications in the first case and navigation or flight controls in the second one. The maximum challenge of this station is to ensure that the aircraft is perfectly finished in cost and quality, but above all, that it is completely safe to start operating it by the crew and the final customer. In this station, we have experienced a great change, having digitized most, if not all, of our daily management routines, such as SQCDP or performance tracker. In addition, we go even further with the use of local tools, such as ALT for overlap and shift change, or one single flow for improvements in manufacturing documentation.
Here's where we paint the A400M. Actually, we are painting the MSN 100 for the German Air Force. The key to this production step is the pre-painting operations. We use many digital tools. Our inspectors use digital tablets where they register all the small non-conformities or non-conformities, and they have a follow-up using these devices. We embrace digital initiatives such as Digital Panel, where we review every day all the information that we need in order to guarantee that we deliver the painted aircraft on cost, on time, on quality.
Hello, my name is David Gomez Esteban and I'm the production manager for A400M flightline in Seville. Today we are in the cockpit of A400M MSN 100 and we are going to do the first flight. The first flight is the most important and crucial point in the production step because it's the final milestone after a work that has been done during months in final assembly line. We're using digital control rooms, we are using one single flow, we are using digital PPS, We're using tablets in order to do the work. And the next steps we want to do is digital bar chart. We want to go for remote support via the tablets. And also we want to use the HoloLens in order to do the work in the aircraft easily. A400M, for me and for a lot of colleagues, is something quite special. This is the place where I have worked for all my career, and I feel quite special when I see the aircraft flying over my head when my son and my daughter. And I tell them, this is my aircraft.